Hey everybody, if you missed the Determining the Stoichiometry of Chemical Reactions lab, this video is for you. We're going to have a chance to collect all of our data here. You'll notice I have a strange setup with these boxes. I basically want a white background so that you are able to see different amounts of precipitate in different graduated cylinders. In order to be successful working through this video, you need to take out the data tables from the lab. And in general, we're doing two different reactions in this lab. One of the reactions is between ferric nitrate and sodium hydroxide, and the other is between copper 2 chloride and sodium phosphate. So let's start off with the iron-containing reaction. This is the one that's FeNO3 plus sodium hydroxide. So what I did earlier in the day is I went through and I did all of these different reactions. Now in the data table, you can see there are several different ratios that I put together. So for instance, I have a 5 to 55 simplified to a 1 to 11 ratio of ferric nitrate to sodium hydroxide. I have a 1 to 5 ratio and so forth down the line. We need to collect data of how much precipitate is formed in every one of those ratios. Now, some of your partners who may have been in class may have lab setups that look like this. So they have very small volumes of liquid in these graduated cylinders. That's because when a bunch of people are doing it in the lab, we don't want to use very large volumes. It's kind of wasteful. So here are some iron-containing graduated cylinders. Here are some copper-containing graduated cylinders. If theirs looks like this, that's all well and good. For us, we're going to use some larger graduated cylinders. So for instance, here's a graduated cylinder that has the iron compound. And the reason we're using the larger ones is so that you can actually measure the volume of the precipitate in each one of these reactions. So again, you need to have out your data table. As we work through the data table, I'm going to show you all of the different graduated cylinders. I had to do this earlier in the day so that the precipitates could settle to the bottom. That's not why I'm not doing the reactions right in front of you. We did them earlier. But with those settled precipitates, I need you to record the volume of said precipitate. So again, if I show you this one, you'll notice that the total volume in this graduated cylinder, let me give you a white background, the total volume in the graduated cylinder is up here. But the volume of the precipitate only goes to down here. So we want this volume. We want the volume of the precipitate in the graduated cylinder because the total volume is in all of them is 60. So we want to know out of the 60 milliliters, how much of it is precipitate. So these are the volumes you're recording. All right, let's take it from the top. We're going to start with the iron 3 nitrate and sodium hydroxide reaction. And let's start with number 1. So this is the 5 to 55. Cylinder number 1, 5 to 55. If you have trouble seeing this, I recommend potentially pausing the video and zooming in. So you can pause whenever you need to. If I go too fast, just pause, and then you can come back and see what you've missed. So that's cylinder number 1. It is the 1 to 11 mole ratio. Here's cylinder number 2. This is the 1 to 5 mole ratio. Again, simply pause if I go too fast. Cylinder number 3. This is the 1 to 4 ratio. And you want these volumes in milliliters. Cylinder number 4. This is the 1 to 3 ratio. Cylinder number 5, 2 to 5 ratio. Cylinder number 6, 1 to 2 ratio. Cylinder number 7, our final cylinder, this is the 2 to 3 ratio. So again, if you're like, whoa, you went way too fast, you can pause the video, you can go back, you can go ahead and record your data. Ultimately, we want to figure out the volume of the precipitate for each of those 7 graduated cylinders. We've just finished all of the iron nitrate sodium hydroxide reaction.
This is Palazzolo. Please call extension 2236.
Let's move on to the graduated cylinders that contain copper 2 chloride and sodium phosphate. So cylinder number 1, this is the 1 to 5 ratio. The precipitates here are going to be blue. Again, you can go ahead and pause if you need to get those volumes recorded correctly. Cylinder number 2, this is the 1 to 2 ratio, 1 to 2. Here's cylinder number 3, 2 to 3 ratio. Cylinder number 4, we've got ourselves a 1-to-1 ratio, 1-to-1 ratio. Cylinder number 5, this was the 3-to-2 ratio. Here comes cylinder 6. Cylinder 6 is the 2-to-1 ratio. And finally, cylinder number 7. Cylinder number 7 is the 5-to-1 ratio. So now that you have all of the volume of precipitates for all of our different reactions, we can go through and we can crunch some numbers. We can start to figure out what the most effective ratio was stoichiometrically, but that is all of your data for determining the stoichiometry of chemical reactions.